All right, welcome to The Explainer. Today, we're diving into a story about a true titan. And I mean that in every sense of the word. We're talking strange new worlds, mysterious giants, and a search for answers that could change everything. So look, when I say the word titan, I know what you're probably thinking. Some giant, world-ending creature from a certain anime, right? Well, the titan we're talking about today is way older, way colder, and it orbits the real giant of our solar system, the planet Saturn. Okay, let me just throw a question at you. Imagine a world out there in our solar system, not Earth, that has a thick, nitrogen-rich atmosphere. A world with weather, with clouds that rain actual liquids from the sky, and with vast seas and rivers that cut through the land. I mean, you'd have to be thinking I'm talking about some kind of Earth twin, right? But here's the twist. We're not. This isn't some old myth or a made-up planet from science fiction. This is a real place. This is Titan, Saturn's biggest moon. And it's this incredible paradox. It's one of the most Earth-like places we've ever found, and at the same time, one of the most profoundly alien. And that's really the core of it, you know? That's the big paradox of Titan. It feels so familiar, it's got an atmosphere, it's got liquid, it's got seasons, but the chemicals playing those parts? Totally different. So let's really dig in and see just how weirdly similar and how incredibly different this moon actually is. Yeah, this chart right here just lays it all out. On the surface, it looks so familiar, right? The atmosphere is mostly nitrogen, just like Earth's, and there's liquid on the ground. But, and this is a huge but, that's where the similarities kind of stop. The liquid? It's not water. It's methane and ethane. We're talking liquid natural gas. And the reason for all this comes down to one absolutely mind-blowing number: the temperature. Get this, an average temperature of minus 179.5 degrees Celsius. It's so cold that water is basically a rock. It's as hard as granite. And methane, the stuff we use for fuel here on Earth, on Titan, it's a liquid that forms entire seas, some of them hundreds of feet deep. Just wild. You know, for centuries, we had no idea what was actually on the surface. Ever since it was discovered way back in 1655 by Christian Huygens, what was under those clouds was a complete mystery. We knew it was huge. I mean, it's bigger than the planet Mercury. And we knew it had an atmosphere, which, for a moon, is super, super rare. Then, in the 80s, the Voyager probes finally flew past. And what did they see? Pretty much nothing. Just this big, hazy orange ball. The entire surface was totally hidden by this thick, planet-wide smog made of complex organic chemicals. We were basically staring at a closed door with no idea what was behind it. And then 2004 happened. Everything changed. The Cassini-Huygens mission, this massive project from NASA and the European Space Agency, finally got to Saturn. And it had a secret weapon: radar. It could see right through that thick haze. For the very first time, we started to map the surface. And what they found? It was just, wow, absolutely astonishing. This was no dead, frozen rock. Cassini showed us a world that was alive and kicking, geologically speaking. It saw these huge seas of liquid methane. I'm talking bigger than all of the Great Lakes combined. It saw massive fields of dunes, but the sand wasn't rock, it was made of organic stuff. And get this, it even found signs of cryovolcanoes. That's right, ice volcanoes, spewing out a slush of water and ammonia instead of lava. Insane. And really, that liquid is the key to the whole thing. Because the most incredible, mind-blowing parallel with Earth is that Titan has a complete weather cycle, just like our water cycle. I mean, just think about how our world works, right? Water evaporates, makes clouds, it rains, fills up rivers, and flows back to the sea. Well, on Titan, the exact same thing happens, but with methane. The sunlight, even though it's faint out there, is enough to evaporate the methane, which makes clouds, which then rain liquid methane that carves out rivers and flows back into these huge lakes. It's a perfect mirror of Earth, just with a totally alien substance. And if you're wondering what's in those seas, check this out. This is the breakdown for Ligeia Mare, Titan's second biggest sea. It's not pure methane. It's more like a cocktail. You've got methane, ethane, and even nitrogen gas dissolved right into the liquid, kind of like bubbles in a soda. Can you even imagine sailing on a sea of liquid natural gas? It's just wild. So, you've got all this complex organic chemistry happening, you've got liquid, you have an energy source from the sun. When you put all those pieces together, it forces you to ask the biggest question of all, the one we ask about any promising world. could there be life? Okay, so before we can really talk about life, we have to talk about something called tholins. It's basically a scientific term for all that reddish-brown organic gunk that's constantly being made in Titan's atmosphere. The best way to think about it is that Titan is like this giant natural chemistry lab that's been running for billions of years, just cooking up this soup of pre-life ingredients that then rains down all over the surface. And here's the simple recipe for how it's made. High up in the atmosphere, UV light from the sun just zaps the methane molecules and breaks them into pieces. Those pieces then stick back together in new ways, forming bigger, more complex stuff, like ethane, propane, and eventually this heavy, sticky material that makes up the smog. And this stuff is always, always drifting down, basically blanketing the whole moon in the potential building blocks for life. This whole setup has led to some really wild, out there ideas about what life could look like. This quote here sketches out one possibility. I mean, forget everything you know about life on Earth. Forget oxygen, forget water. Picture an organism that breathes in hydrogen gas, eats a chemical called acetylene, which is all over Titan, and breathes out methane. This wouldn't just be a new species, this would be a completely different kind of life, a second tree of life born in a totally alien environment. But of course, it's not that simple. Just because you have all the ingredients doesn't mean you get a cake. The hurdles are huge. For one, the insane cold means all the chemical reactions would happen super, super slowly. Water, which is so crucial for life here, is frozen solid as a rock. And liquid methane, well, it's just not as good as water at dissolving things and getting the chemistry of life started. So what we have is this massive puzzle, a world that's overflowing with the raw materials for life, but in an environment that seems almost designed to stop it from ever starting. So how do we figure it out? There's only one way. We have to go back. And if you look at our history with Titan, it's been a story of these incredible jumps in knowledge. I mean, we went from seeing it as just a dot of light in 1655 to getting that frustratingly blurry orange picture from Voyager, to the absolute bombshells from Cassini and the Huygens probe, which, by the way, actually landed on Titan in 2005. But the next step, well, it's on a whole other level. And this is Dragonfly. Just look at it. It's a car-sized drone, a quadricopter powered by a nuclear battery. In the mid-2030s, this thing is going to arrive at Titan, and it's going to fly. It'll hop from spot to spot across the surface, sampling the ground, tasting the chemistry, and looking for any signs of life, either now or from the distant past. This will be the very first time we've ever had a powered aircraft flying on another world. It's history in the making. And that really brings us back to the ultimate question, the one that Dragonfly is being sent all that way to answer. Is Titan just a frozen museum, perfectly preserving the kind of chemistry that happened on Earth billions of years ago, right before life got started? Or is it possible that something actually did start there? Against all odds, did life find a way in those freezing seas of methane? Is there a second Genesis waiting for us? Honestly, whatever Dragonfly finds, it is going to completely rewrite what we know about life in the universe, forever.